Hey guys, I hope you've had a great week. It's been some very, very busy times here at Works Plus. We are getting well and truly down the line here, very, very close to World of Concrete, just around the corner. Something I want to talk about today that hasn't been... All right, who was that guy? Something I wanted to talk about that we haven't really touched on so far, but it's a reality of being a concrete grinder. And that is really that when the machines are running, they're making money. But when they really cost us money is when they're not. So we're going to be talking today about some of the, the evolution of troubleshooting, getting the machine back in action and making money. And so we're talking about a little bit of the evolution from where it's come from, started, where we kind of expect it today, and I guess where we can take it to. So follow me, we're going to go and see Tim and Hayden, see what they got to say.
Hi everyone, we're back. I'm standing here again with St. Hayden, and we're going to just take our conversation a little bit differently today. We're going to wander away maybe from the mechanical and the build quality and the geometry, all those sorts of things of the machines. Today we want to talk a little bit more about the machines when things go wrong.
Things go wrong.
When there's problems, when there's troubleshooting, when there's issues. When a machine is not behaving the way it's supposed to, and we're all asking the question, why?
That's right.
How do I fix this so I can get this thing back up and running and we can get back to productivity?
That's right. And when do these things go wrong? When the machines are working, which is usually when we're not here.
I love them when they break down in the shed on the weekend.
It's great when that happens.
When no one's using it.
That's right. That's
Most
right.
Convenient time.
It is.
We don't tend to get those calls.
No, we don't really have breakdowns in the workshop either. It's odd. It's odd.
It's a bit late.
That's odd.
But Hayden, you are extremely used to this part of the grinder's life, the machine operator's life. You've worked in the workshop, ran the workshop, very closely associated with workshop for a bunch of years now. Lots of tech support, lots of calls. If anyone could tell us a little bit about the sorts of things that people are regularly calling up, trying to fault find, and the way we've done that traditionally, historically, and even up to date, it's you. So let's have a little bit of a discussion about when things don't go wrong, how we go about it.
Sounds good.
How do we deal with it?
Well, I mean, usually it's a phone call to me because, it's we've got a luxury of having the door open on the machine, on this particular machine. But I guess in general, most of the machines, they're covered up, all the electrical's covered up. A lot of them have exterior panels that you can't get into and things like that. So it can be an issue because, the handlebar controller on here, there's no information on this. The machine's either working or it's not. So usually the first thing we're asking someone to do is open up this door and start talking to us about what's in here. Second problem usually is, you start talking about, all right, I need to get some values out of the frequency inverter. They look and go, oh, my screen doesn't work, or I haven't got my glasses.
So when we talk about the frequency inverter, we're talking about these boxes, okay? They're essentially a computer.
Correct.
And we would say that traditionally this has always been our point of truth.
Correct.
Okay, because the frequency inverter is essentially the brain. It's the connection point or the intersection point with all the controls. The motors are plugging into it basically. So essentially the frequency inverters, bit of a mouthful.
It is.
Frequency inverters have always been the point of truth where we can derive a lot of information out of them. We can see what sort of RPMs the motors are running at, or the frequency. We can see what sort of current it's pulling. We can see what sort of voltage the machine's getting from either its power supply or from its generator. We can see whether the potentiometer, the speed range, is doing its thing. All of that information is available in here.
Yes.
Okay. The problem is you need to know how to look for it.
That's right.
I'm glad to see you brought your glasses today. That you're wearing your glasses, Hayden.
I came prepared.
Because you know as much as I do. The historical context for dealing with this is someone on the phone. Okay. Machine operator on the phone, door open like you've said. And
usually trying to run the machine as well.
We need someone to push buttons for us, so we can navigate different menus in this thing to get this series of data out.
That's right.
To run some diagnostic tests, but it's all been
on the phone.
On the phone. The amount of times that people go, I can't see because I didn't bring my glasses today. I'm glad they're only doing first cut, not having to get not checking for scratches.
That's right.
Because that would be quite a problem. So, and they were relying on a mobile connection too. So, you know,
in the basement somewhere, you know, reception. All of a sudden, I'll just go down and check that.
Yep.
5 minutes later, the phone rings again. There goes an hour of your day.
Yep. So, talk us through a little bit about how do we get into these things, and it's been very helpful in the past.
It has.
But obviously, we're going to be talking a bit today about how we've progressed from this. Yep.
Yeah, I guess, look, primarily, again, you know, this particular brand and design machine has 2 frequency inverters in there. A lot of them only have 1 if they're a single head machine, or single motor machine, sorry. So depending on the brands, types, there are some differences on them. But on this particular one that we're fairly heavily used to, we can get into this, you know, it starts up on a particular menu. We can go through and check all the amps, as Tim was saying. Usually we have 3 parameters that we want to know out of that, that we heavily rely on for both fault finding and for performance at the end of the day. So we want to know we want to make sure the machine is reaching the speed reference that we're asking it to make sure the machine's not under too much load. Therefore, if it's not reaching that, there's going to be other problems. We want to make sure it's not, you know, pulling too many amps, or make sure it's pulling enough amps from a performance aspect as well. So it's important to know how many amps you're pulling to tell your tool's working hard or are they working too hard, and then the machine's going to start playing up hard to handle because it's hitting its current limits. Outside of that, as Tim said, we have what we call a DC bus voltage, which gives us a good indication of what's coming into the machine. You know, if that's dropping down low, like on a generator, or you're a big industrial factory and there's 27 other machines running, your voltage will drop, and that's a key thing to know if that's why something's happening. You know, can you work around it by turning your speeds down, things like that. So the information that's in here to us is a key piece of the puzzle when you're operating a machine. So a lot of guys, you know, this is actually a pretty clean one, but a lot of guys run these machines with the door open all the time because they're now so used to looking at these and measuring off these data points. So I guess, yeah, from our experience, you know, the next step up from this was the remote control machines.
Well, just before we go to that, I guess the other thing that we've experienced doing this in the past too is there's static tests we can do. So we're sitting here behind a machine that's not running, and we can do things like, you know, unplug motors, plug them in, and all that sort of stuff. And then there's things we actually have to
run the machine.
We have to run the machine. So we're relying on guys to run a machine, sometimes push machines, and keeping them going on the floor, trying to look in the box. It all gets pretty comical, really, at the end of the day.
Oh, absolutely. I feel for the guys on site when I'm asking them to do some of these things, and you know, you hear them telling you how hard it is to hang on to. But yeah, unfortunately, in a lot of these series, it's the only option to really try and get an answer without just saying, pack it up and bring it in.
Then there's obviously the issue of error codes, okay?
Yes.
So these frequency inverters, they store an error code. Every time a machine logs an error, it stores that code. Some of them store lots of errors.
Correct.
Some of them only store very few. So for instance, this particular brand of drive, I think stores only 5. Now, every time they disconnect the power to the machine, it comes up as an under voltage.
Correct.
So if they've disconnected if they've stopped the machine 5 times in a row, they're only going to have 1 error code, which is the machine under voltage. So if the machine did have a problem and it stored the error for the actual problem they had, and they've started and stopped the machine or powered it down and powered up to try and reset it a handful of times, we've lost the error code.
That's right.
Right? But even if we did have the error codes are pretty meaningless.
Yeah, in a lot of cases.
The EO1 or F11 or F16 or something like that, without the manual or without some other way of deciphering what that is, it's all
a phone call again.
It's all Greek, right? So let's just talk a bit about, there has been a bit more of a development in the industry over the last 15 years or so when it comes to relaying some performance criteria or data back to the users, plus error codes. Let's have a little bit of a chat about that.
So definitely, you know, once we started moving into remote control machines, some of, not all of, the data became available on the remote control. Error codes as well, a lot of those you did have come up. Manufacturer to manufacturer, some of them were useful, other ones, you know, came up with just contact service agents, things like that. It doesn't help an operator. It just tells you there's a fault. You got no idea on site what to look for or even try and fix it in that regard. So even with those, even with the remote control version of these, a lot of the time we'd be asking the customer, what's the actual drive still telling you at this point? Even though you got it on the screen, on the remote, what's this one telling you? So you still have to open that door.
And then of course we have the scenario where we get the telephone call after they've packed up and they said, listen, machine's not working, I need to do something about it, can I bring it in? And we go, well, how about we do a couple of tests first while you're still there? And they go, oh, we're already on the way over.
Yeah.
So even in that case, we may have been able to solve the issue, but once the thing's disconnected from the power, no more information to access anymore, we're flying blind again.
Right.
So,
and I got to say, I reckon 50% of those, when they turned up here, ran fine. And it was usually a site power issue. So
yes,
again, being able to see all this on site and know what you're looking at.
So having meaningful performance information, having meaningful error logging, and error logging that actually is captured and saved. I guess communicating that error and what might be the
giving pointers as to what to look for, what area of the machine has gone wrong,
underlying issues. And then of course, what else falls in that category? Other types of diagnostics and other information. Yeah,
of course.
Right. So we've gone from the really old school, really dumbed down, simple, whatever we can get out of there while they're turned on, and if they've got the error codes and if the guy's got the glasses that can help us, to a more user-friendly radio control setup, which now you can start seeing on a screen, how hard the machine's working, what sort of speed settings, still quite limited information.
Absolutely.
Error logging, like you're saying, different levels of meaningfulness, depending on the operator and depending on the context. But we think we've taken that a little bit further.
I think we have. Absolutely. Yeah.
In order for us to talk a little bit more about that, we're going to have to take a little bit of a walk, go and see some other key people in the company.
Go and see a specialist.
Go and see the specialist because it's definitely got beyond my ability to talk about it. I'm very comfortable with this, but where you and the team are taking it now is next level. So how about we go and check in on the guys that are responsible for that part of the machine development and see what they've come up with.
Sounds good.
Well, Hasty, here we are. Headquarters, Works Plus headquarters, upstairs, right where all the cool kids hang out. Right. They're cool kids because there's air conditioning here as opposed to where we've just come from in the back factory. So we're a little bit envious of the working environment. But you said just before that we needed to go and see a specialist.
Yeah.
You had a
particular
specialist in mind.
He's a specialist. This guy.
Would you like to drop this name of who this specialist is?
His name is Josh Van Der Veen.
We've come to see Josh Van Der Veen.
Sorry.
Hang on, sorry. No. We've come to see Josh Van Der Veen, just not this Josh Van Der Veen. The Josh Van Der Veen we're actually come for is this Josh Van Der Veen. No, you're not seeing double. So, quick intro. This is Josh Van Der Veen. This is actually my eldest son. He's part of our R&D team and IT team here at Works Plus. Got his degree in computer science and coding and all that good fun stuff. And he's the specialist. He's the Josh Van Der Veen that we've come to see regarding this one. So, Hayden, I know you and Josh have worked very closely together with regards to this project. I'm going to hand my mic over to the one and only Josh Van Der Veen.
Tim and I have been talking about error logging, all of our data that we track with customers. So when there's a fault or a problem or for performance. Obviously, we've spoken about from the original machines that it's all via the frequency inverters direct inside the cabinet. Now, obviously, we've gone remote control machine, so we've obviously got a lot more data coming up to our screen now for operators. But we've taken a step further than that. We've also got some information here on a computer screen by the look of it. So we have we've incorporated into our machine some remote login capabilities. So whether that be from tracking, so GPS tracking, through to tracking all of our different speeds and things. Now, looking at this, you can actually see, the machine looks like it's just stopped, but the machine is actually running down in the back factory right now. Not right this second because it's turned off for some reason, but JJ, what have we done? What have we got here?
So we've tapped into all the other components that are on the machine, and we pull that data out so that we can see that remotely. So that will send it to the cloud, where we can look at that. And as you can see, the machine current is changing, and that's all in real time. So we can help you work out all the issues or monitor your machine and see how it's going remotely, so we can help support you like that.
So from a support perspective, we have access to this.
Yep.
Right. Do the customers themselves have access?
Yep, so the customers will be given access so that they will be able to see all their different machines, what they're doing, the location of them, and all these other different pieces of data that operators will want to be able to see.
So we say this is going to be a really big step for a lot of operators, and even for business owners that have got multiple machines. They can see live what a machine's doing. They can see live what error codes have come up.
Yep.
If an operator's having dramas on site, we can see all of this live, but not just the live data, we can look at previous data as well to see when a machine is running, if there's something that we can flag remotely from an operator user point of view that might be assisting putting towards the problems that they're having. So even from a training perspective, trying to train new operators, all the information is here for someone to look at and review to see how they can improve what they're doing.
Yep.
So I guess, should we go and have a look at the,
Just to prove we're not pranking.
just to prove that we're not making all this up, we'll keep this running in the background, and let's go down and have a look.
Let's go.
All right, so here we are. You've had the little tour. You've been to HQ upstairs. We're back in the hot, sweaty R&D nerve center. And we're just going to show you that we weren't pranking you before when it came to that beautiful dashboard you saw upstairs on the desk. We're down here. We've got a radio control. We've got the laptop. We've got a machine, and we're gonna start it up so you can actually see what's happening. So maybe flip the laptop around. So here we are. Everything's essentially dormant on standby mode. We'll just hit our vacuum. We're going to switch the machine on. And you can see, there's our live data. Same machine that we were running before that you couldn't see. Now you can see it's running. And if we just scroll over here into our little dashboard on the radio control, I don't know how well you can see that. But if you don't have your laptop handy, or you're not sitting in a nice air-conditioned desk, you can get all your information straight there, off one of the menu screens, in the actual radio control transmitter console. So it's all there, it's all live, it's all captured, and it's all there to be helpful and to make all of our lives easier. So there you go. That's our little thing to talk about today. It's as easy as that. You can turn it all off again and start again tomorrow.
That was, I'd say, very insightful, and I can see how that's going to be very, very practical for contractors, people who are running these machines in the future. And really impressive to finally meet you, Joshua, and be introduced to all of the skills that you bring to the table. Part of the team, as they say, it takes a village to make a machine. You know, the one when lots of people make good outcomes and stuff. Speaking of which, I think it's time we go and have a weekend. Thanks for watching, guys. I'm really looking forward to the next one.